All right, welcome everybody to today's special Solar World Congress at 50 follow-up webinar hosted by the International Solar Energy Society, ISES. We are very pleased to have all of you here and we are good to go now. My name is Arabella. I am the Congress's Communications and Outreach Officer here at the ISES HQ in Freiburg, Germany, and I will give you a short introduction into ISES and the work we do, as we have many new participants joining us on the webinar today. The International Solar Energy Society ISES is a non-profit UN-accredited membership NGO. Our vision is 100% renewable energy for all, used efficiently and wisely. ISES represents a diverse membership of academics, researchers, energy practitioners, consultants, students, businesses, and advocates. ISES works together with like-minded organizations from countries all around the world to advance the renewable energy transformation. There are many benefits to joining ISES as a member, and you can always learn more on our homepage. Some of the benefits are the exclusive access to presentations and webinar recordings, such as today's, in the ISES webinar archive. ISES members can also get discounts and even free registrations to ISES events and partner events. Every month, ISES publishes a newsletter for our members where you can follow our progress and share your news. And members can obviously also subscribe to our academic journal, Solar Energy, the flagship publication of our society. As a special benefit to all attendees of today's webinar, we are very happy to offer a special discount when signing up as an ISES member. All attendees of this webinar will receive a 20% discount code as a follow-up to this webinar over the next few days. Now, I'm happy to introduce you to our Solar World Congress 50 introducer, Paulette Middleton. Paulette is an atmospheric chemist, and during her 40+ years of career, she has held leadership positions at different research institutions, as well as working on the Global Emissions Initiative Gaia, and working as a coordinator and science-based environment energy advisor to a wide variety of public and private and stakeholder consortiums through her own company, Panorama Pathways. In addition to being an ISES board member, Paulette is also the past co-chair of the American Solar Energy Society, the US section of ISES. Today, Paulette will introduce us a bit more to Solar World Congress 50, and she will set the stage for the webinar. Now, I'm happy to hand over to Paulette. Paulette, thank you for joining us. The floor is yours.
Good morning, good afternoon, good evening, and welcome to this webinar. We're so excited. The Century of Solar, and I'm going to be brief so we can get to the meat of this webinar, but we've been celebrating the Century of Solar, the Solar World Congress 50, since last December. We had, at that point, we had a 2-day virtual conference, which was looking backward from the last 50 years and forward to what we need to do, especially in this decade of disruption that we are in now, which we're all confident will get us to where we need to go very soon within this next 10 years or so. We have as a wonderful ongoing activity, the booklet, which will be updated every couple of years, includes much about the history and pioneers, as well as the looking forward, and also a solar museum. Just very briefly, for over these past 60 years, members of ISES have undertaken technical research, product development, and advocacy for growth of solar and renewable energy technologies. So just again to underscore, Solar World Congress 50 celebrates what's been achieved over the 50 years since the first international conference and discusses what must happen over the next 50 years with particular emphasis on the next 10 years, this decade of disruption. So the conference, the booklet, the museum, and special webinars provide resources to help everyone celebrate the transformation to a 100% renewable energy world. Finally, we would like to thank our sponsors and then the many people who contributed and continue to contribute to the booklet and the museum. And here's what we're reaching out to you in the audience for. Please send more contributions, comments, and donations to continue work in support of the ongoing booklet and museum. And I just want to list the main organizing committee and give a special shout out to Jeff, our chair, and Monica, who did a great job of putting together this wonderful, wonderful webinar that we're about ready to enjoy. So you can take my screen off now and put on the slide introducing Hannah. Thanks. Thanks, everybody.
All right,
so
here we go.
We're very excited today. Our moderator, Hannah Murdoch. Hannah, somewhere there on the screen. Yes, there's Hannah. Hi. So she will be moderating this webinar. She directs research on policy and on transport as part of the research direction team at REN 21. I'm sure that everybody in the audience knows about all the wonderful work that REN 21 is doing. She is lead author and coordinator of REN 21's flagship report, the Renewables Global Status Report, and coordinator of REN 21 activities in the NDC Transport Initiative for Asia, as well as other transport projects. In her decade of experience in the energy sector, she has held various research roles working within NGOs, national organizations, academia, and consulting. She holds master's degrees in international energy policy from the Paris School of International Affairs and in public administration from the University of North Texas. Welcome, Hannah, and thank you for being our wonderful moderator today.
Thanks for the introduction, Paulette. Going to see if I can get my screen shared. You can confirm that everything's showing up okay?
Can confirm.
Great. So I'd like to also thank ISES for organizing this webinar on such a crucial topic. As kind of a general introduction before jumping into the more detailed presentations of the panelists, I'm going to give some of the background kind of high-level trends on the transport sector and on the role of renewables in decarbonizing the transport sector, drawing from the latest edition of the Renewables Global Status Report, which is REN 21's flagship publication. And we just released this last June. So in case you're not familiar with REN 21, we're the only global renewable energy network of passionate experts committed to building a sustainable energy future. REN 21 is a multi-stakeholder organization made up of governments, international organizations, the private sector, NGOs, and science and academia based at the UN Environment Program in Paris. So jumping right in, the past year offered some bright spots despite the pandemic, particularly for the power sector. Although the early phase of the pandemic was difficult for renewables, new renewable power capacity hit a record increase globally, and renewables were the only source of electricity generation to experience a net increase during the year. More than 250 gigawatts of new renewable power generating capacity was installed in 2020, and installations were well above the installations of the year before, growing almost 10%. In 2020, 83% of global power capacity additions were renewable, which is the 6th year in a row that net additions of renewable power generation capacity clearly outpaced net installations of both fossil fuels and nuclear power capacity combined. There were also several net zero targets announced, demonstrating kind of a global shift in ambition. But there's still a clear gap between the net zero ambitions announced over the past year and the reality. Obstacles that have prevented the growth of renewables in the past years continued during 2020 and together have led to a slow increase in the share of renewable energy in final energy demand. At the same time, the world is burning more fossil fuels than ever. Since 2009, the share of fossil fuels in final energy consumption has remained the same at 80%, and global energy demand has expanded around 20%. Renewable energy now meets just over 11% of global final energy demand, but that's only a slight increase from around 9% a decade earlier. While there's been really incredible progress in the power sector for renewables, That's mainly where the advances have stopped. The transport sector accounts for about 1/3 of total final energy consumption globally, and yet has the smallest share of renewable energy at only 3.4%. And over the past decade, the share of renewable energy in transport has increased by just over 1 percentage point, from about 2% 10 years ago to just over 3% today. Despite the increase in EVs in recent years, the overwhelming majority of the renewable contribution to the sector continues to be from biofuels. Also, over this decade, transport energy demand has grown more than 22%, which is problematic considering the sector continues to be 97% dependent on fossil fuels. Transport has also seen by far the largest growth in energy demand compared to other sectors, nearly all of which has been met by fossil fuels. This figure shows energy demand growth over the 5-year period leading up to 2018. And as you can see, the transport sector is not only seeing the most growth in energy demand, but also is in by far the worst shape in terms of dependency on fossil fuels. So it's no surprise that with the increasing energy demand in the transport sector and the continued dependency on fossil fuels, emissions have grown for transport about 40% since 2000 for every sector of transport except for rail, which saw a decrease of 2% over this time. Looking at national targets, nearly all 2020 targets for renewables in transport had not been achieved according to the latest data. And about 1/3 of the countries that have targets had not set new ones as their 2020 targets were coming to term by the end of the year. Countries aren't meeting their targets in large part because of the lacking supportive policy frameworks, or because the policy frameworks that exist are ineffective or not enforced. The number of countries with support policies for biofuels in transport actually plateaued in 2017 at 65 countries globally and has not increased since. Electric vehicles can play a role in increasing renewables in transport if they're powered by renewable electricity. But EV policies and targets have generally lacked a link to renewable electricity. There are targeted bans on fossil fuel vehicles that have been increasing in recent years. They're now in place in just 19 countries, though, globally, up from 17 a year before. And this is indicated by the stars in the figure here. But many countries with EV targets are targeting only low shares of renewable power, and some lack national renewable power targets altogether. In terms of policies linking EVs with renewable power, there are only 3 countries globally that have an EV support policy that has a direct link to renewable power. That's Germany, Austria, and Japan. The economic recovery packages for COVID-19 provided an opportunity to reorient investment. But despite international calls to build back better during the crisis, investment in renewable energy and recovery packages was almost 6 times less than for fossil fuels. Of the more than $700 billion announced in spending to support energy by 31 countries through early 2021, 42% was allocated to fossil fuel intensive sectors and 22% to other non-sustainable energy sources, while only 7% was allocated to renewables. At least on the bright side, 29% was allocated to energy efficiency and enabling technologies such as EVs. So when we're talking about decarbonization of transport, we have to always keep in mind this avoid, shift, improve framework, avoiding the need for motorized travel, shifting to more sustainable modes, and improving efficiency, technology, and fuels. And I think the tendency in the renewable energy world has been to focus mostly on fuels, while the tendency in the transport world has been to focus mostly on avoid and shift and only efficiency under improve or only on EVs. But all of these are undoubtedly crucial for an energy transition for the transport sector, and renewable energy cannot be left out of the equation. What's needed for decarbonization of the sector is policies that focus on all of these areas and inclusion of renewable energy as a key performance indicator under improve. This is in addition to removing conflicting incentives such as fossil fuel subsidies and increasing coordination across sectors and ministries for more comprehensive, holistic, long-term planning. And while it's clear that a structural shift to renewables is required across all sectors to meet global climate goals, progress isn't going to happen until we are tracking the right indicators. These can be tracked using a simple key performance indicator of the renewable energy share, as this reflects developments in energy demand, energy conservation, energy efficiency, and emissions, in addition to renewable energy uptake and the reduction of fossil fuel use. We need to dramatically speed up this transition. This doesn't mean moderately increasing the share of renewable energy from one year to the next. It doesn't mean gradually lowering the contribution of fossil fuels. It means transitioning from fossil fuels to a renewable energy-based system in all societal and economic activities starting today. The question is if we'll act fast enough and take sufficient measures to make a difference. And here I'm just slipping in a quick plug for our upcoming work on this topic, because views on this vary quite dramatically. RIN21 is focusing the next edition of the Global Futures Report on the future of the transport sector. And we'll look at forward-looking questions presenting a collective thinking of many experts on the question of what will be the role of renewables in decarbonizing the transport sector? What will the future of the transport sector look like? So you can get involved if you're interested by going to rin21.net/GFR for Global Futures Report to sign up to get involved there. Otherwise, I'd invite you to check out our website at rin21.net, where you'll find much more information on energy and transport, as well as all of our reports, summaries for policymakers, interactive microsites, and all figures and data available for free download. So thanks for your attention. And with that, I'll give the floor to our first panelist. So Tony Wood has been the director of the energy program since 2011 after 14 years working at Origin Energy in senior executive roles. From 2009 to 2014, he was also the program director of clean energy projects at the Clinton Foundation, advising governments in the Asia-Pacific region on the effective deployment of large-scale, low-emission energy technologies. Tony, over to you.
Great, thank you, Hannah. Now, I'm assuming that is, okay, I assume we've got that now. Okay, well, thank you very much for this opportunity.
Tony?
Yes.
Could you switch so that we can see your full screen? We are seeing your presenter mode.
My apologies.
No worries. You can, if you click on the 3 dots in that little circle down below.
Oh, yeah.
And then there's hide presenter view, I suppose. Yeah. And then this should give us.
Is that better?
Yeah, this is awesome. Thank you.
Okay, great. Thank you. Okay, so look, in the next few minutes, I just want to give you a little bit of a picture on some of the work that we've been doing in trying to understand how we actually do shift the transport sector to net zero emissions. And in Australia, we have some particular challenges, and I'll briefly explain what they are. Australia is a relatively large physical country with a relatively small population of about 25 million people. This has some implications for transport because it means that we are highly dependent upon road freight for moving stuff around. Our cities are relatively young, and that also means that when they were growing, they just expanded physically, and so we became far more dependent upon personal cars for transport. And in fact, something like 56% of homes actually have 2 cars or more. We also do consider ourselves to be people who drive a lot. Now, most of us do not, but we have an image of wanting to drive into the country, into the bush, as we call it, and that has an implication as well. At a climate policy level, climate war has been a characteristic of the political landscape in Australia for the last 20 years, and it remains so. As a consequence of that, our national government, its target for its INDC under the Paris Agreement is a 26 to 28% emissions reduction below 2005 levels by 2030. This is not amongst the most aggressive on the planet. However, interestingly, all of our subnational governments, our states and territories, have committed to net zero by 2050, although they do not have policies to achieve that situation. In the last 10 years, all of our car manufacturing facilities in Australia have closed because of simply they were overwhelmed by scale. So companies like Toyota, Mitsubishi, General Motors, Ford no longer manufacture personal motor vehicles in Australia. And over the last 20 years, almost all of our refineries have closed. We now only have 2 refineries, all the rest of our diesel, petrol, and aviation fuel is imported. So there's been quite a dramatic change, and that has some implications, what I'm going to talk about. This is a chart that quickly shows a snapshot of Australia's current and projected emissions. And you will see from this chart that the vertical axis, top left-hand side, we are producing somewhere in the order of 500 million tonnes of carbon dioxide equivalent today. Of that, about 1/3 comes from electricity generation. Transport is about 20%, and industrial emissions is about 30%. So they're the big ones. Agriculture for Australia is significant, but not as big as those other 3. The challenge is that it's of these sectors, electricity is the one that's been reducing, and that's reflected in what you've already heard from Hannah, that in Australia, for example, renewable energy now reflects something like 25% of our electricity delivered, and that's increased quite significantly and is consistently increasing. On the other hand, you can also see from this chart that just about everything else is either flat or slightly decreasing. So what that means when we turn to transport is that at about 100 million tonnes here, as I said, about 20%, we have seen a COVID-related dip in 2020, 2021. Mostly that was it wasn't evenly spread across the applications of transport. But this chart shows you that the government's current projections to 2030 suggest that there will be a recovery. We're obviously very optimistic in Australia about the way we're going to get out of COVID, and that will more or less maintain a reasonably static level of absolute emissions from transport through to 2030, despite the fact we're going to see some changes. What that means, of course, is if we want to be somewhere towards net zero or zero by 2050, the slope of that curve is dramatic, and it reflects an annual reduction in emissions from transport, which every year is as sharp as what we've seen under the year of COVID. So it puts that in perspective. Now, turning to transport, about 60% of the emissions in Australia in the transport sector come from cars and light commercial vehicles, or LCVs, and about 20% comes from trucks, articulated trucks and rigid trucks. This is probably not that unusual globally. I guess our overall emissions in transport are slightly lower than those numbers that Hannah showed you on an international basis, and part of that is simply because as a country that has been dependent upon coal-based power generation for a long time and still is, relatively, emissions from power generation and heavy industry manufacturing have outweighed emissions from transport. So the challenge, if we're going to do something about this, to bend that curve I showed you before, is to do something about cars and LCVs, or light vehicles in combination. Now, what, to my own personal surprise, I discovered as we did this analysis, is that while the average age of vehicles on our roads is about 11 years, the average life expectancy is about 20 years. And what that means is if we have to get anywhere near zero by 2050 in the light vehicle sector, remembering that other sectors of transport and the rest of the industry will be even harder, then we have a big challenge. Because if we don't start to bend that curve quickly, then cars that are on the road in 2030 and 2035 will still be on the road in 2050 and 2055 unless we do something else about it. The barriers to zero emission vehicles are the things you see everywhere else in the world. We do not have a large range of vehicles at the moment. 0.7% of sales last year were electric vehicles. We also are a country that's somewhat unusual for an OECD country, has no vehicle emission standards and no vehicle efficiency standards. And that has been a political problem for governments. And there's some part of those reasons, of course, are associated with the fact that we used to make cars. The upfront cost of EVs imported into Australia is quite high, and as common with many countries, the concerns about access to charging are significant. So what we've recommended in our analysis is the most effective way to move from where we are now to make a big difference would be to introduce a vehicle fleet emission standard. Now, these are not unusual in the world. In fact, President Biden announced that using a fleet emission standard in the United States only in the last couple of weeks. The reason this is we think is the best policy rather than direct financial subsidies, at least at now, is because we're such an early adopter stage. A relatively modest subsidy in terms of reducing the cost of the vehicle up front probably doesn't change the intention to buy of the early adopters who are buying those cars. The big issue is how do we actually start to make more vehicles available, a greater range of vehicles available, and for a while allow more efficient internal combustion engines, because that also takes away some of the political challenges associated with effectively forcing people to move away from their favourite vehicles. Of course, at the same time, we should scrap some of our inefficient taxes, which will largely put in place to protect the Australian vehicle manufacturing industry, which, as I said, no longer exists. And finally, there are a number of other things we can do which are important, and we would have this in common with other countries. These are removing some of the barriers to the uptake of electric vehicles. And to some extent, there's a combination of whether these vehicles turn out to be fuel cell electric vehicles doesn't worry me so much, although most likely, I guess, batteries will continue to dominate. We do have challenges with our National Construction Code, that's for buildings, to ensure that they have access to vehicle charging. Like many cities, we have many people who don't have access to off-street parking. And we also have a major problem, and again, I guess we share this with many other countries, where we do need tariff reform to encourage smart charging, particularly time of use charging. So what would happen if we did this? Well, the chart on the left-hand side shows what would happen if we achieved a level of sales which was close to 100% EVs by 2035. Now, it may be there's a small leakage, and we're not saying that we should ban electric vehicles. We're simply saying that by then there effectively would be a financial penalty or an extra financial impost as a result of purchasing electric vehicles, purchasing internal combustion vehicles. What would happen, of course, is the EV sales would increase.
Hey, Tony, this is Arabella. Can you move the GoToWebinar panel a bit to this side? Apparently, we are seeing it. Thank you.
That's still there?
No, all good now. Sorry for the interruption.
Okay. What would happen in the bottom left-hand slide, it shows is that the share of sales would be quite high. That is close to 100% by 2035, 2040, but the share of the fleet would increase steadily and be very close to 100% by 2050. Over the current projections by the government are those two dots you can see there, and unless you start to bend the curve, even though the bottom dot is not very far from the bottom line, it doesn't move, and so you just do not close the gap. As a result of that, if we were to achieve that sort of change, then we would see significant emissions reduction from vehicles. Now, something's happened with my slides because I can't. Here we are. Sorry, my apologies. So the rest of the sector, I'm not going to cover aviation or shipping because that's other people will cover that. I will just briefly make a couple of comments about heavy vehicles. We have, as I said before, large distances, and we are highly dependent upon road freight. even more so with the fact that the planes aren't flying very much, and so we need to move all that stuff that we buy over the internet has to be moved by road. In our view, like many people, we would see a combination of electric and hydrogen fuel cell vehicles. We don't yet know what the mix is going to be. And so what we're suggesting, we're going to need to run some targeted trials, and we are already seeing in Australia, as elsewhere, hydrogen fuel cell trucks being imported to this country, even for the very long distances where trucks have to travel effectively the full length or breadth of the country, many thousands of kilometres. One thing we do have, which is a bit unusual, we have a truck width limit in Australia, which means that many of the trucks that come into the country have to be modified. This is fundamentally not justified by any real practical problems, and therefore we're certainly recommending that be changed. At the very bottom of the slide, it just simply says that, as I said, you would have seen from my previous slide, that rail, buses and motorcycles in Australia is pretty small and probably at this stage not worth worrying about all that much. So if we did this with trucks, you would see if we had a share of share of sales that was even 20 or 30% by 2035, 2040, the share of fleet would still only be 40 or 50% by 2050, because again, trucks tend, even though the trucks that are used by the very big modern trucking companies that we mostly see around our cities, a lot of those trucks end up in retirement, doing a lot of mileage, working for farmers, working in remote parts of the country, and so they stay on the road for a long time. So I don't think we can ignore trucks completely at all, but the trucking side just looks a bit harder. So finally, here's what we ended up recommending. We suggested that we need to reduce the barriers to zero emission vehicles. That is, we need to increase the availability of zero emission vehicles for Australians to meet their real needs. We need to do something about the upfront cost, and we certainly need to improve the access to charging. The emission standards, I said before, and so forth. Under heavy vehicles, we absolutely should amend the truck width limit. That would make a big difference to the availability of trucks in this country and reduce the cost of having to modify them. Secondly, we do need trials for zero emission trucks, and some of those are already beginning. And one of the challenges here is yet whether or not we'll be able to adopt on-site hydrogen generation for those sorts of trials. And those sorts of trials are already being planned and will happen over the next several years. And a lot of the major truck companies are already very keen on this. In addition to that, a lot of the big mining companies who have their own truck fleets on site in Australia are already trialing zero emission vehicles, trucks of various sorts, even though their distances are not all that great. And finally, we're suggesting we should establish a renewable hydrocarbon standard as a hedge against hard to decarbonise transport tasks, because we do not want to just simply be left where we are. So in summary, I think we're in a position in Australia where there's a lot to be done. There are some political challenges to getting it done, but the opportunity is there. On the light vehicle side, the solutions are clear. The heavy vehicle side, there's work to be done. But I think we can, if we can bend those curves and start to bend those curves between now and 2030, we will be in good shape to adopt the vehicles as they become cheaper to own and to operate, and we will head towards net zero by 2050. Thank you.
Thanks, Tony. So now we'll move to the next presenter. And just as a reminder to our audience that's listening in, feel free to put your questions in the Q&A box now, and we'll come to those at the end of presentations. So up next, we have Rimo Shapi, who is a doctoral student at the Professorship of Renewable Energy Carriers at ETH Zurich. He holds a master's degree in mechanical engineering from ETH Zurich, and his research is focusing on the production of solar fuels and the demonstration of the entire production chain from sunlight and air to liquid hydrocarbons. Rimo, go ahead, the floor is yours.
Thank you for the introduction. I'll just wait a second until my screen is sharing.
Yeah, screen is looking fine.
Yeah, it's just I can't see my presentation on my side at the moment, so I'll need to. Yeah, here we go. So thank you very much again for the introduction and welcome also from my side. As mentioned, my name is Remo Schappi. I'm a PhD student in a group of Professor Aldo Steinfeld here at ETH Zurich, and I will talk now about solar fuel production from ambient air in a modular solar concentrator reactor system. So I'm going to talk about a technological demonstration under real field conditions of this entire process chain. As a brief background as we're now talking aviation fuels, fuel use and CO2 emissions of aviation, currently the commercial aviation sector is causing about 2 to 2.5, even 3%, depending on the source of the total anthropogenic CO2 emissions, which is about 12% of the CO2 emissions from any transport sectors. If we have a look at these graphs underneath here, quite briefly on the left-hand side, we can see that the total fuel consumption of commercial airlines worldwide has been increasing quite a bit in the last years. Of course, now we have a ditch here in gray, the current COVID pandemic. Also, the predictions for the future. So, for example, here the sustainable development scenario for 2025 to 2040, that was, according to my knowledge, done before the COVID pandemic, also is still thinking of an increase in aviation fuels, sustainable aviation fuels with a slight increase, as you can see here in blue. These sustainable aviation fuels here, they're basically mainly biokerosene. What I'm presenting today is another option. Also, quite interesting to mention in the background is that actually the percentage of the total anthropogenic CO2 emissions caused by the aviation industry is increasing every year. So it also shows that targeting this part, the aviation industry, is becoming more and more important also in the future. Now let's briefly see how fuel production usually works. We take crude oil out of the ground, put it in refineries and produce our liquid fuel, which we then burn in either road transport, ships, or as I said, in airplanes, so in the aviation sector. It is clear here that for cars, for example, as we heard before, or shipping, as we'll probably hear next, there are other options to get away from liquid fuels, for example, EVs, hydrogen cars and so on. But for planes, for the foreseeable future, we will stick with liquid fuels due to various reasons. The fuel that is burned there in a plane, for example, is then releasing CO2 in the atmosphere, and we have the classical one-way street of CO2 released in the atmosphere. So the question that we ask ourselves now is, how do we get the CO2 back out of the air into our liquid fuel, and of course without using the fossil part of this, but powering this circle, for example, by the sun. If we can power the circle by sun, our liquid fuel is becoming a renewable fuel and is also a CO2 neutral fuel, as up in combustion over here on the left hand side, it will only release as much CO2 back in the atmosphere as was previously captured from the air in the first place on the left hand side. Further, quite a big benefit of this type of new fuels is that we can use existing infrastructures and technologies, so we don't need to develop new engines, new distribution networks. We can use the current existing pipelines, tanks, and so on. And our fuel is, even though renewable and CO2 neutral, in drop-in fuel, so we can mix it directly with other commercial jet fuels, for example. And that means we can introduce it bit by bit without having to change the entire system. So let me show you how we actually demonstrated this entire process chain here at ETH in Zurich. So we start with ambient air, out of which we take CO2 and water in a CO2 and water capture unit. So running an adsorption-desorption cyclic process with a temperature and pressure swing. CO2 is then stored, compressed and intermediately stored. Water is also stored in liquid form. I want to point out here that we do not only capture CO2, but also the water directly out of the air, because also the water we need for our process. CO2 and water is then fed in our main system, the solar dish reactor system, where we use the concentrated sunlight to heat up our reactors and produce syngas, which is then compressed again and fed to our synthesis unit, where we produce our solar fuel. So where did we build this entire process chain? We built it on the rooftop of our university here in Zurich. The building on the left-hand side, that's the main building of our university in the middle of Zurich. And you can recognize again the container here, the CO2 and water capture unit, the intermediate CO2 buffer storage tank, the optical dish system, where we use the concentrated sunlight, the syngas, then analyzed in the control room inside, from which also the entire process chain is monitored and organized. It's then compressed again outside before it goes to the synthesis unit, again inside the lab. You can see that we managed to demonstrate this entire process chain on top outside on the real field conditions in an area probably less than 10 by 10 meters. And by bringing the technologies out of the lab, out on the real field conditions, that's a next advancement for this technology. Our core system is this dish reactor system. So the optical system is basically between 4.5 and 5 meter diameter parabolic mirror that is tracking the sun at all times during the day based on mathematical curves and a solar sensor. So the incoming solar radiation is reflected, concentrated, then reflected again on a flat planar secondary mirror that focuses on our 4 instruments. We've currently 4 instruments installed on our dish. We have a Lambertian target for flux measurements, a water calorimeter for power measurements, and then our 2 solar reactors to the left and the right-hand side. Underneath here on the right-hand side, you can see a flux map of our system. And you can see that with this optical system, we can reach peak solar concentrations above 5,000 suns and peak or averaged over the aperture of the reactor, indicated in the white circle here, exceeding 2,000 suns. This allows us to run our solar reactor, which is basically an Inconel shell with an alumina insulation, a water-cooled front with some radiation shields, and a quartz window. The quartz window allows us to close the reactor and run the reaction also under vacuum. And the core of the reactor is a so-called Seria RPC. RPC stands for reticulated porous ceramic. So it's a special ceramic structure developed in-house in our lab, made out of pure ceria or cerium dioxide, which has a dual scale porosity. So we have pores in the millimeter scale, but also in the micrometer scale. What we run here is a redox reaction. So we first have a reduction where we reduce ceria and release oxygen, typically performed at temperatures of up to 1500 degrees and under reduced pressures of down to about 10 millibars. This is then followed by an oxidation step. So we oxidize ceria again with CO2 or with water, or we can do co-splitting of CO2 and water combined. That will produce as CO and H2 our syngas. The oxidation typically performed at temperatures below 900 degrees and at ambient pressure. What you see here is an exemplary cycle of just CO2 splitting. We can see in green the temperature heating up, in this case up to 1400 degrees during the reduction. It's then cooling down again. We start our oxidation towards the end. In red, we see the pressure swing during the cycle. In black here, the oxygen evolution during the reduction, followed then by the CO evolution during the oxidation. Now we do not only have 1 but 2 reactors installed on our dish with the idea that while 1 reactor is receiving the concentrated solar radiation and performing the solar reduction to produce oxygen, the second reactor is performing the oxidation with CO2 and water and producing our syngas. If both reduction and oxidation are terminated, we simply switch the concentrated solar radiation around. So now the second reactor is receiving the concentrated solar radiation, performing the solar reduction, producing oxygen. The first reactor is cooling down. We feed in CO2 and water, performing the oxidation and producing our syngas. Switching the solar radiation between the reactors, we simply turn our secondary mirror, as you can see here in real time on the left-hand side, where we move the focal point from the reactor on the left over to the reactor on the right-hand side. This allows us to do fully automated full-day exemplary cycles. Here an example of a CO2 splitting only. Again, what we see here in blue and red lines are the temperature swings of the two reactors. The background color indicates which reactor was on sun at what time. In circles, we have the oxygen produced over that cycle, and in asterisks, the CO produced in that particular cycle. To give you some numbers, during this particular day, we had a power input of up to 5.9 kilowatts with a mean solar flux concentration of about 2,360 suns. Average peak oxygen evolution was 0.29 milliliters per gram Syria per minute, with an average total O2 evolution of 1.44 milliliters per gram Syria. Average peak CO production 0.31 milliliters per gram Syria per minute, with an average total CO production of 2.89 milliliters per gram Syria, averaged over all the cycles. Over the entire 32 consecutive cycles of that particular day, that gives us 338 liters of carbon monoxide. Together in separate streams, 168 liters of oxygen. And if we do the ratio between CO and O2, we see the ratio is almost exactly 2, which shows that we can close the mass balance over the entire day. Solid to fuel efficiency, defined as the calorific value of the fuel divided by the solar energy, the solar input, plus some penalty for inert gas splitting and pump work, on this particular day was about 3.8%. I want to point out that this was not optimized for efficiency. How could we further increase the efficiency of these cycles? We can, of course, optimize the operation parameters and the actual setup. We can optimize the porous ceramic structure inside the reactor, so the reactor core, to make it, for example, all participating, for example, by means of 3D printing and so on. This is a project currently going on in a lab as well. Another big increase is possible if we start looking into heat recovery. Also, this is a project currently going on in our lab. And you can see here we have quite a big temperature swing from 14 or 1500 degrees down to about 550 degrees. This heat at the moment is basically lost. If we can recover some of this heat, that will increase our solid to fuel efficiency by quite a bit. After this syngas that we produce of our solar dish reactor system, it's compressed and then fed in our synthesis unit to produce our solar fuel. For demonstration purposes, we did methanol synthesis and produced methanol, but with the same equipment, we could also do Fischer drop synthesis here and then target, for example, jet fuel, kerosene as an option. I want to point out here that depending on what type of fuel we want at the end or the synthesis we want to perform, we can really tailor make our syngas to the exact needs of the synthesis by adjusting the CO and water flow in the beginning entering the system. So the system is very variable and can really tailor make the syngas up to the needs. Same reactor technology, we also performed an upscaling attempt in the so-called Sun to Liquid project that was in Móstoles, south of Madrid in Spain. Partnering here ETH from Zurich, our lab, with the DLR from Germany, MDI Energy in Spain, and High Gear, the Dutch company. Here, the reactor was not stationed on a dish, but also only on a small tower, optical height 15 meters, with 169 heliostats focusing the sun up onto our reactor. The reactor here is a 50 kilowatt scale. The one that I showed you before was around 5 kilowatt scale. This project actually produced kerosene with a Fischer drops unit. So we used the syngas from this reactor in the Fischer drops unit to produce kerosene. I also want to point out that this type of kerosene is already certified for use as aviation fuel. And this, if we want to further upscale, of course, the idea would go to higher towers as currently used in, for example, CSP plants. and we could build these plants also in deserted areas, so we don't have competition of land use and so on. What is an issue, of course, if we talk about biofuels. And with this, I'm nearly at the end of my presentation. I would like to acknowledge my funding companies. Thank you very much for your attention. And should you have any further questions after the Q&A session, here are my details in case you want to contact me. Thank you very much.
Thanks, Remo. And now we're going to change to another sector of the transport sector, and that is on shipping, looking at Gavin Albright, who's the Secretary General of the International Wind Ship Association, which is a not-for-profit organization promoting wind propulsion solutions in commercial shipping. He currently also sits on the IMO MTCC Network Stakeholder Advisory Committee, is a non-executive board member for the World Wind Energy Association, a work package leader on the EU Wind Assisted Ship Propulsion Project, and an advisor for other decarbonization and wind propulsion research projects. So now, without further ado, over to you, Gavin.
Okay, thank you very much. Can you hear me there?
Yep, sounds good.
Yep. Okay, great. And I think my slide should be coming up now. Can you see that? There we go. Can you see my slides?
Yes.
You can. Great.
Slideshow mode.
Yep. Okay. Oh, just a moment. Okay. Are we okay there?
Yes, looks good.
And I'll try and get that minimized as well. So put that down there. Okay, so thank you very much for inviting me to talk today. Really delighted to join our friends at ISES and also to be moderated by Hannah from REN21. We can't compete with the century of solar, and we wouldn't want to do that. So I'm going to welcome you to the decade of wind propulsion. This was a campaign that we launched earlier this year, of course, and really this is about the delivering on the promises of direct wind propulsion being brought back into shipping for propulsion purposes. Now, shipping has quite a difficult to abate reputation. We're talking about ships with that are very long-term assets, between 20 to 40 years. So pretty much all of the ships that are designed and built today must be operating in a net zero emissions world by the end of their service life. And that is a real challenge because we're only really at the start of bringing renewable energy and renewable low carbon fuels into the shipping industry. But one technology that is available and is growing, as I will be showing you, is that direct use of wind propulsion. Now we're talking about between 60 to 100,000 vessels, and right now we're not on a very good trajectory to actually deliver on these promises. So what we're talking about with wind propulsion is the direct application of wind power. So Remo just earlier on was walking us through that process from the reactor of development of alternative fuels, and those are going to be extremely important in shipping. The front runners being ammonia, hydrogen, methanol, some biofuel use, batteries for short sea shipping, that type of thing, and power to X, so power to gas or power to liquids. But one of the problems is that you have vessels far from shore needing to be bunkered. A lot of energy loss will be occurring there. Whereas with wind, it's delivered directly to the ship at the point of use for free for the entire length of that 20 to 40 years, without the need for infrastructure, without the need for storage on board. Can it deliver 100% of the power to vessels? Well, yes, it can, but it's more likely, especially in the early periods, to be delivering around 5 to 20% as retrofits, potential with optimization up to 30%. But then when we've got optimized new build vessels coming through, then we could be looking at well above 50% of the propulsive power delivered to the vessel. And just to give you a very quick snapshot, there are actually 7 different systems of direct wind propulsion, everything from hard sail through to kites, through to rotor sails, which are rotating cylinders which catch the wind, so mechanical sails, to your soft sail, which most people will appreciate from sort of Pirates of the Caribbean, or anybody that watches any leisure yachting. Suction wings, which are a stubby wing that actually has a suction device within it. Turbines, which can produce both electricity and power thrust, and also the development of hull forms, where the hull of the vessel becomes a wing in effect. Now, I'm going to try and place this within the decarbonisation drive in the industry. We look at this in 3 trends that are developing at the same time, but at different paces. So the tweak, the transition, and the transformation. The tweaking is what is happening substantially at the moment, which is the retrofitting of those vessels, and a huge number of smaller vessels as well. And that will actually extend the carbon budget by 20 to 30% over the entire fleet, giving us more time to move into that transition. And the transition is where the new vessels that are being built are actually optimized far more for wind, either as a wind assist, up to that 30–40%, or as primary wind vessels. And then as that's developing, there's a lot of R&D going on into transformation, and these are things like MOL, which is was the largest Japanese shipping company, is actually doing research into harvesting additional power from your wind systems, turning that through turbines into electricity, and creating hydrogen or some other form of fuel on board, potentially even turning ships into tankers. So creating 100% renewable energy at sea and then delivering that to port. So there's some very exciting transformation projects that are underway as well. Now, to put that in context, on this tweaking aspect, we look at this from a hybrid wave point of view. So wind, pretty much if we go with a conservative estimate of around 20%, that's the retrofits and new builds coming in, tied in with activity, which is optimizing the way you're using your vessels. So reducing speed, having virtual arrival, software on board, improving the training of your crew, weather routing, which is very critical for wind as well. So we've got satellites, we've got LiDAR helping with those benefits. That could deliver another 20%, tied to vessel optimization. So these are the ship efficiency measures, design, etc. Again, conservatively delivering around 20% of savings. So putting those 3 together, we're looking at around about 60% of the energy either delivered or saved before we start looking at the eco-fuels. And that's reducing that nut, that very difficult, expensive nut, 300 million tons of fuel, reducing that down to a more manageable amount. And that could actually accelerate the uptake of those more expensive and energy intensive fuels, because we need that energy intensity, especially liquids or gases. But when the gas is there, it's either got to be cryogenically stored or under pressure. And this was a question that we asked just recently, and we did a thought exercise around this. Could wind propulsion actually fund the decarbonisation of the fleet? And I won't go through all the stats that we used, but we were very conservative on this. And it's been estimated around between $1.4 to $1.9 trillion are required to decarbonize the entire fleet using fuel. If you bring wind in, the savings that you're creating actually will pay for those wind installations within 3 to 4 years, but then start delivering substantial savings over the coming decades. And we were able to estimate this at around about $1 trillion plus the 300 billion being used to implement wind propulsion is pretty close to delivering on that cost, and probably within the first few years of the 2050s would actually cover that. Now, just very quickly, a snapshot of where we are today and then a forecast going forward. We have 15 large ocean-going vessels with wind assist systems already installed, and by the end of this year we should have 20 of those. Those are supplemented by well over 20 small-sail cargo, fisheries and cruise vessels. They cover all of the segments from tankers, bulkers, ro-ro, ferry, cruise, general cargo and fishing vessels. The one that's missing here is the container ships, and these are huge, they lack deck space at present. So there will be a trade-off there between fuel saving and cargo amount. However, systems, for example, that are off the deck, like a kite, can be retrofitted to container ships without losing that cargo capacity. So there's potential for a lot more coming through the pipeline. Market forecast, well, I love to talk about wind, as you can probably tell, and I could give you lots of numbers, but we like to use third-party forecasts. 2030, we're looking at around between 3,700 up to 10,700 installed systems. This is from an EU report, and we think that that's actually conservative because it only used 3 or 4 technologies, only looked at 3 or 4 technologies, and also really only focused on containers, tankers, and container ships. Bulkers, tankers, and container ships. The UK government pushed that out to 2050s, and the research around there looked at around about a 45% penetration in the global fleet. Again, we feel it could be much higher. This is a very busy slide. I'm not going to go through all of this, but this just shows you some of the project news over the last 12 months. We've got some very big players. The most recent one is actually the one on the right here, the inflatable wing sail by Michelin. They are coming into the wind propulsion segment. We have Renault tying up with one of the groups here. We have Cargill coming in, Vale, some very big companies working with members of our association to deliver on these systems. But I'll leave that slide for you guys to look at more detail at your leisure. And just very quickly touching on some of the drivers and barriers, we've heard quite a few of these already from Hannah, from Tony, on policy. These issues are incredibly important, and we're working on those. The one that I would actually like to just quickly touch on is the perception side of things. Wind propulsion in shipping, of course, we have a few millennia of experience in shipping using wind. So pretty much we're bringing back an old way of propulsion and making that new. And it's interesting that in the wind generation area, if I say a wind turbine, you think of a gleaming white electricity generating turbine. You don't think of a 17th century Dutch windmill. However, when I mention wind ships in shipping, pretty much in your mind's eye, most people will be thinking Jack Sparrow, Black Pearl, Pirates of the Caribbean. And that is very much not the case anymore. So that perception is starting to change. People in the boardroom are also changing and appreciating that more. And we have a number of projects and collaborations underway. Again, I won't go through these in detail, but the EU is funding 5 installations under the WASP project, which we will be releasing validated data on the performance of those over the coming 12 months. There's also a project with ABS, the American Bureau of Shipping and Marin, which is looking at all of the performance indicators, regulatory perspectives, etc. And we're also establishing a wind propulsion accelerator with a test fleet to actually bring forward and bring innovations into the market far quicker than they are currently. And this is my last slide. It's just we like to call it a win-win-win situation. All of these companies, and there's some very familiar companies for all across different all across different industries. All of these companies, all of these organizations are engaging with wind. Some of them are installing it. Some of them are looking into and assessing their fleets at the moment. Others are working on the R&D certification and delivery of wind propulsion systems. So it's moving now from what was a peripheral development in shipping is now coming into the mainstream. We're not quite there yet, but it's being taken a lot more seriously than even 5 years ago. So it is a decade of wind propulsion. As Paulette mentioned, it's a decade of disruption. I think that's disruption in many different ways, climate disruption, but also industry and technology disruption. So difficult times, but also exciting times going forward. Thank you very much.
Thanks, Gavin. That was really interesting. Now we're going to move to the question and answer section of the webinar. So I'd invite all of the panelists back to this virtual stage. And to start off, we've gotten a few questions in the question and answer box. So keep throwing your questions in there. And I'll start with one that came for all participants, and maybe Gavin, you could take the first stab at this. With the latest UN report coming out about global warming this week, the IPCC report, it was not very promising. And even though the share of renewable power is increasing in the transport, in the energy sector overall, we see the share of renewable energy across all sectors is going much more slowly. In your view, and perhaps within your specific sector of expertise, what would you see as the main mistakes or missed opportunities? Basically, what have we done wrong so that emissions are still not under control? And what would be the main starting point for going in the right direction now?
Yeah, I think a lot has been done right. I think that the scaling and the choices that we have to make are still a great challenge. I would say probably the biggest mistake, and I've highlighted it in my presentation, is around this hybrid approach. Is that we tend to emphasize, or the economy tends to emphasize, commoditized fuels, commoditized energy sources. And we tend to neglect or put it at the side of saying, oh, it's an efficiency measure. So we have a very fuel-centric view. It's an efficiency measure if we're, for example, heating our house with passive solar, or we're heating our water with a solar water heater, or wind propulsion in shipping. How do investors, how can they see, other than the installation, where is their sustainable financial return? Because pretty much once you put a wind propulsion system on a ship, there is no energy payback for that company. So whereas with hydrogen, you put a hydrogen system in and you keep selling hydrogen to that ship for the next 30, 40 years. So there's a revenue model there. I think we need to be very honest around this and say, look, there are some models and some areas that don't have those clear financial returns or easy to quantify financial returns, but we need to be integrating these across the board. So reducing the amount of energy that we need, emphasizing passive or non-commoditized energy, and then topping up, and it's a tremendous top up, but then also looking at all of those fuel-based activities as well. And that's very easy to say, not very easy to implement.
Right. Yeah, of course. Tony, I don't know if you could speak to the same question, thinking about land transport on what we've done wrong so that emissions are still not under control.
Like, I think what we've done wrong, and I guess what we've done wrong is why haven't we made as much progress as we should have been making, is a lot of it's been to do with a combination of politics in many countries. It's been climate change has been a political weapon used very aggressively in some countries, and Australia is certainly one of those. And in addition to, I think what we've just always underestimate how quickly we can move when we put our mind to it. So we're actually optimistic, but we see all the barriers. It's a lot easier to see the barriers. It's a lot easier to model all the challenges. It's a lot easier to see the cost. It's harder to imagine what's going to happen. And you only have to look at find anybody who got anywhere near predicting what the cost of solar would have been now 15 years ago. And the same thing's going to happen with fuel cells. The same is going to happen with electrolyzers. So, and maybe it'll happen with sort of other technologies you've seen from my co-presenters in this seminar. So, once we unleash that, then look out. And I think the thing that makes me more optimistic, Hannah, is that it won't necessarily be dependent upon politicians to do all of this. Some of it will be important to have good policy direction, but what we're seeing globally is global supply chains are being affected. The financing sector, the regulatory sector, all the organisations who are responsible for the prudential authority sector, they are all putting pressure on companies to change the way things happen, and those companies are putting pressure on their suppliers to change things. So, European car manufacturers are insisting not only that they're going to make electric vehicles, but the materials from which their cars are made also have to be low emissions, like the steel, the aluminium, and so on and so forth. So that's changing rapidly. And even in Australia, which is a country that provides a lot of food, we're seeing major global agribusinesses are looking for countries that can produce lower emission food, so more sustainable food. So I think there's enormous potential here, enormous opportunity. What we have to do is find those policy levers that will unleash the market structures and unleash the finance to make it happen, because there are no really technical barriers to going a long way. The last bit might get harder, but we're nowhere near there yet.
Right. Yeah, quite a challenge. Remo, I guess, for aviation, it's potentially even bigger challenge. From your view, I mean, what have been the major missed opportunities to getting aviation emissions under control? And maybe a linked question to that would be, what are still the remaining technological barriers to scaling up to industrial scale, the types of technologies like that you're working on, that you've shown us?
Yes, thank you very much. So maybe for the first part of your question, I think what has been done wrong. I mean, I think to some point aviation's always been a bit put on the back as well, because as we saw before, there are available options for a lot of cars, for example. Already the technologies are already there. For example, the technology I presented today is not quite there yet, so that needs more investment. And one of the things is also in aviation, we're talking of a quite worldwide market. So the first one, it's all interconnected. So the first one to move might have a disadvantages against someone else. So that's also making it a bit harder to implement changes. And then the economics are really important, and is down to the fuel at the end of the day. So unless there is an actual economic incentive to change something, no one is going to move unless there is going policies towards that and introduce a quota system or something. So then to the second question, like what the challenge in upscaling of this particular technology that I presented is, as already mentioned, of course, the material, the core, there is a lot of improvement there that can be done to make it also more robust, stable over long term usage. Heat recovery also, as mentioned. And then when just further upscaling, then size of such reactors are limited to some point, mainly, for example, the size of the window, the sheer size of a window is a limiting factor. So we foresee like an array of such reactors on top of solar towers. And then of course the integration is absolutely key to match mass and energy flows between all the different subsystems and ensure the quality of the flows between all these different subcomponents.
If I could add one more thing, Hannah.
Go ahead.
You know, with what Remo's talking about with aviation and with shipping, we have international and to a small degree rail, but these two sectors are international sectors, and it's in many ways, and especially with shipping, you've also got the issue of where do the carbon emissions actually lie? Do they lie with the ship owner? Do they lie with the cargo producer? Do they lie with the fuel producer? The flag of the ship? All of these aspects. It's very, very complex, and this is one of the reasons why it was left out of the Paris Agreement, along with aviation, because they just couldn't come up with a global solution. And you've got to get 170 countries pretty much on board to come up with a policy structure that works. And this is why we're not seeing the carbon taxes as yet, or carbon levies coming in there as well. So I think that's also a failure in that global coordination around these two, particularly international global sectors as well.
Mm. And there has been some movement, I guess, with ports coming together to have climate goals, the international scale, but that's also just one part of the problem. I guess someone had mentioned rail. I think it was Remo talking about this, but I'm wondering for Tony. One of the questions that came from the audience was the possibility of moving to rail as a less carbon intensive mode of transportation for both freight and commuting, as this rail is the most highly electrified transport sector, and it also has the highest renewable energy share among the transport sectors. So could that be a possibility in Australia?
Look, I think the let's call it city and regional rail, I think the answer almost certainly is yes, and most of that's electricity anyway, and certainly in Australia and many other parts of the world. So, as our electricity system becomes renewable, that will change. And I think, this will be, we talked, Gavin talked about the decade of wind. I think we're talking about the century of electrification. And so, we're going to see all of these things move to electricity. We'll move away from gas as well. So what I think the longer distance rail is more of a challenge. And I think, the extent to which it's been an experience in Australia. And one of the problems we have here is that, one of the characteristics is, as I said before, modest to middle-sized cities. I mean, Melbourne, Sydney, Brisbane, so forth are, 3, 4, 5 million people. So they're not tiny, but they're a long way apart. And so moving things around relatively is quite expensive. And we've also found that rail systems tend to be quite inflexible in that sort of situation. And so the road freight transport is really dominated. It's hard to see that changing in Australia. And so I think, therefore, the rail, what we will see more likely, in my view, is that hydrogen fuel cells will be the answer for both road and rail for longer distance. And, I think that the really exciting thing about this is that, the point at which renewable hydrogen becomes cost competitive with existing fossil fuels, and particularly diesel, which is what we mostly use for longer distance rail and trucking, is a much higher point where the economics favor switching to renewable hydrogen than it is for many of the other applications for hydrogen. And so that becomes one of the really interesting opportunities, and particularly if some of the transportable local on-site production of hydrogen from renewable energy comes down in costs, then I think that's what we'll see moving quite quickly. And as I said, I think earlier in my presentation, there are already companies who are bringing in hydrogen fuel cell vehicles into Australia. And these are not just relatively small trucks. These are trucks that haul 2, 3, and even 4 trailers, what in Australia we call road trains. And I think that's going to be where this is going to go. And I think that means that we will remain very much dependent upon longer distance road freight, but it will almost certainly, in my view, be the hydrogen fuel cells.
Yeah, it's kind of fascinating how quickly these things are moving. We weren't talking so much about hydrogen a few years ago, and then all of a sudden it's everywhere and every single conference. And same with, I mean, electrification. When looking at scenarios from 10 years ago, you don't see as much of a role of electric vehicles. So things change really quickly. Maybe a question for Remo here on that note is, considering you're looking at a newer technology here, are you working with any airlines that are trialing this method? And are also you seeing any current leaders or front runners when it's coming to decarbonizing aviation?
I mean, we, for example, in our lab, we have a spin-off company that is looking into upscaling these technologies. And we also, as our lab, we have been approached by airline companies to see what's going on. And we are in a continuous discussion also when it comes to what maybe goes with policies and so on. So specifically, yes, airlines that we can see show some interest in the technology. Also, normal fuel companies are looking into different options. That's quite interesting for us because they obviously bring in a lot of know-how when dealing with certain parts of the fuel, maybe not the solar part. And yeah, so some airlines have announced that they would pay for certain renewable fuels if they would be available and so on. Any particular details of a certain companies or front runners, I can't name you, but there's definitely interest there. Of course, the technology still needs to go further quite a bit, so we're talking of a lot of investment at the end of the day as well, but signals are there that these companies are interested in these type of fuels.
Well, that's at least a promising sign. Yes, I'm conscious of time. I know that we're coming toward the end of our scheduled time for this session. There are far too many questions in the Q&A to get to, unfortunately, but potentially there will be a way to answer those offline after the webinar. I think Arabella can let us know about that. But I'd like to give the panelists another opportunity to give kind of a takeaway, or maybe something that we haven't touched on yet that you'd like to share with the listeners. Perhaps we can start with Gavin. If you'd like to go first.
Yeah, well, I think I've probably run through the whole thing on wind propulsion. So taking that away, I'll go with something that maybe is a note of caution when we are moving or needing to move so quickly. And indeed, our association called for a strategic review of shipping and all of the aspects of the energy transition on the basis of two main things. One is comparing oranges with oranges, having a level playing field, being very, very careful about a full well to wake, as we call it in shipping, life cycle analysis of all of the aspects of all of the fuels, all the infrastructure, incorporation of all externalities into that analysis. So direct, indirect subsidies, things like health costs, climate costs, etc., etc. And frankly, that's not really being done. And I'll give one example from the IPCC report, which is they were very strong on the methane issue, and we need to be looking at that from a 20-year global warming potential perspective rather than a 100-year, because we simply that is where the climate is being forced. And if we're multiplying the impact of something like methane by 3 times, if we're looking at that over a 20-year period, I think we need to incorporate that into all of the equations, all of the choices and decisions that we're making around policy. So that's a very big, wide, broad one, but wind propulsion obviously is the answer to everything. That is a joke, by the way. But, yeah.
Tony, how about you?
Somewhat of a windy joke though, Kevin. I think for me, it's almost obvious in a sense, but it's more important than it can sound, and that is that what we're challenged to do is to bring together the right balance of, we need all three. This is like a three-legged stool. The technology is important, and the technology is great fun, and it's exciting. And as you said, Hannah, everybody's talking about hydrogen. Michael Liebrecht used to run Bloomberg, compares it to the Swiss Army knife. It's got all these little attachments. Hydrogen can do all these things. There's only a few of them it does well. And picking out which those are going to be is going to be really challenging. So the technology is really fun and exciting. What's going to be critically important is to get the right balance of technology with policy and markets of finance. And that's going to be the challenge, because it's not a shortage of money in the world. There's a lot of money trying to find a home. There's a lot of cheap debt trying to find a home. It's trying to find the investments to put that money into. And most of the issues are not really technology either. Given the right incentives, people will invent the stuff. It's getting those all three in lined up. When you see them lined up, the power that you unleash is extraordinary. And when you see them out of sync, you see how much of a mess we can get ourselves into. And you know, the country that I live in is in a bit of a transition at the way of getting ourselves out of what's been a mess. We are fixated on the technology. We haven't quite got enough of the policy and the finance yet lined up to support the technology, not just to develop it, but to bring it through into the market. So when the sort of things that you heard about wind and the idea of making liquid fuel from solar, when they come to be anywhere near commercially viable, you then need the markets, the policy to pull those through. And I think getting those three all lined up is the critical factor if we're going to get to net zero by 2050.
And Remo.
Yes, I mean, I think from my side, I would just want to point out that it's interesting now. We saw loads of different options as well, especially like wind. Even there's not the one solution. There is loads of different options to tackle the same problems or slightly different problems. And I think that's it's important to keep in mind that we need to keep going down that way as well, to not only look for the one true solution, that there are different options. There's different options to come to the same goal, and also give them a chance. The options that are not technology ready or not there yet, but give these options a chance, create maybe a chance for them. And then there's, if we talk about solar, for example, there might be at a certain point an option for Africa to start producing fuel and deliver that. Maybe we wouldn't never build such things in Norway or in these areas. So, but I think there are options for different countries as well, and for to use different technologies for specific needs. And I think that's quite good to keep in mind, that we don't focus just on one road, but keep it open to new ideas as well.
Yeah, and Paulette, I guess maybe you can close us and
yes. Well, I think, Hannah, I'd like to invite you, before I say a few closing words, to tell us your thoughts, your final thoughts.
Well, I guess in the slides that I had shown earlier, kind of the main takeaway that I think I'd like to just repeat, so that it kind of hits home, is that I mean, we're seeing this huge increase in the power sector in modern renewable energy, but it's not enough, and we still just have kind of spiraling energy demand, so that fossil fuels are staying basically the same as they have been the past 10 years, all the way going back to 1990, still 80% fossil fuels. So we really have to think about a fundamental change in the system, so that we start going in a different direction. And I think there's a lot of potential in the transport sector to make a dent finally in this.
Oh, it's wonderful. So I have two quick comments. The first one, I'm just reflecting on the wonderful comments around the technology that we've just had. Struck with the summary of Back to the Future. When we were writing up the booklet for Solar World Congress 50, I think maybe Jeff, it was Jeff Stapleton who pointed out, we had the solar age for thousands of years. Then we had this little blip of fossil age. And now it's kind of like we're going back to the solar and wind. And so I kind of think that's a beautiful way to think about it. The second thing I just want to mention is not only about the technology and the financing and the policies and all those coming into good alignment, as you mentioned, Tony. I think that, you know, it's the political will. We see the future. We know we can get to that 100% renewable energy world, and we can do it even faster than by mid-century. We just have to keep our eyes focused, our vision, and our actions focused on making that happen. And one thing along those lines is also such an important part of that is that we all have to be really good Jedis in order to bring everybody on board into this wonderful new world. And of course, Jedi means justice, equity, diversity, and inclusion. So let's hear it. Let's all be good Jedis and get to that world that we want to have for all. So back to you, Arabella, for your final comments.
Yes, thank you very much, Paulette, and I will keep in heart to be a good Jedi moving forward. And I think the presentations we heard and saw today, they are the inspiring kind of presentations we need to keep our Jedi hearts moving forward. Yeah, and now that we've closed the Q&A session, there are only a very few closing comments from my side before we say goodbye for today. And that first one is, we get asked a lot, and yes, it is true, these webinars are being recorded, and you will see them coming online on the ISES homepage in a few days. And for our ISES members, please do remember that you have the unlimited access to all ISES webinars already. They are in the ISES webinar archive. And then another biggie this year for ISES for sure is our upcoming Solar World Congress 2021. As with everything these days, it's going to be a virtual conference. We just opened registration for this last week, so it's still all very new and exciting. And so we do encourage you to sign up and to join us in October. We do have a range of early bird tickets available, and those are going to be available until the end of September. So if you want to be smart about it, go and register now, because that's going to be a good decision to make for sure. Yeah, so definitely join us in October. And I think with that, it's my closing comments now. We do very much appreciate your feedback. If you have any questions or things you want to share with us about the webinar, there's going to be a little survey launching for you at the end now. So if you have a few minutes to spare, it would be awesome if you could complete it for us. And then there are many ways of getting in touch with ISES, or better said, staying in touch with ISES. You can find us on all relevant social media channels, and obviously just reach out to us at the office. Yeah, and I think with that, I'd like to close for today. Thank you to the speakers, and thank you to Hannah, of course, for coming online and for joining us this afternoon. Yeah, and with that, I say goodbye to everybody.